Welcome to qnawire.
We are given a random variable which follows exponential distribution with mean 2.415. So the probability density function PDF is fx of x is actually equal to 1 over 2.415 e power minus x over 2.415 when x is greater than or equal to 0 and 0 otherwise. Now we will also find the cumulative distributive function CDF, which is also written as capital F of x, which is actually 1 minus e power minus x over 2.415. Yeah. Now let's go down with the questions. So for subdivision A, we are supposed to find what is the probability that the rainfall is at least 2 hours. So at least 2 hours can be written as x greater than or equal to 2. So this can also be written as 1 minus probability of x is less than 2. And probability of x is less than 2 can be obtained by the CDF. So 1 minus e power minus 2 over 2.415 is actually e power minus 2 over 2.415, which is 0.4369. So the probability that the rainfall is at least 2 hours is 0.4369. Now the second subdivision asks us to find that the probability is at most 3 hours. The probability that the rainfall is at most 3 hours. So at most 3 hours can be written as x is less than or equal to 3. So again this can be obtained from CDF. So 1 minus e power minus 3 over 2.415. So this is actually 1 minus 0.2887. So this is 0.7113. So the third subdivision asks us to find the probability of the rainfall which occurs between 2 and 3 hours. So this can be found by calculating the probability which is less than 3 minus calculating the probability which is less than 2. So 1 minus e power minus 3 over 2.415 minus 1 minus e power minus 2 over 2.415. So simplifying, I get e power minus 2 over 2.415 minus e power minus 3 over 2.415, which is 0.4369 minus 0.2887, which is 0.1482. Thus the probability of the rainfall which occurs in between 2 and 3 hours is 0.1482. Now we'll go to question B, where we are asked to find the probability of the rainfall which is exceed more than the mean value more 3 standard deviation. That is, let mean be represented as mu and standard deviation be represented as sigma. So we are supposed to find what is probability of the rainfall greater than the mean plus 3 times standard deviation. So we are given mean mu to be 2.415 and the standard deviation can be obtained. Let's say this is lambda, and we know that the mean and the variance are equal. So I mean, let this be lambda squared, right? No, let this be lambda, and we know that sigma is actually equal to square root of the variance, which is lambda, which is 2.415. Yeah. So we'll calculate what is mu plus 3 sigma. So that is 2.415 plus 3 times 2.415, that is 9.66. So we are supposed to find the probability where the rainfall is greater than 9.66. It can be written as 1 minus probability of x, which is less than or equal to 9.66, right? And the probability of x is less than or equal to 9.66 can be obtained by cumulative distributive function. So this is 1 minus e power 9.66 over 2.415. So that is just e power minus 9.66 over 2.415. So that is 0.0183. And therefore we arrive at the answer where the probability where the rainfall is greater than mean plus 3 times standard deviation is 0.0183. And the second subdivision goes like this of this question. To find the probability that the rainfall is less than mean plus 1 standard deviation. So we'll find what is mean plus 1 standard deviation. So that is 2.415 plus 2.415, which is 4.83. So we are asked to find the probability where the rainfall is less than 4.83 hours. So which is 1 minus e power minus 4.83 over 2.415 by using the CDF definition. So this is 1 minus 0.1353. So this is equal to 0.8647. So the probability that the rainfall is less than mean plus 1 standard deviation is 0.8647. Hope you understood. Thank you.